Good afternoon, everybody. So my name is Mathias Coopmans. I work for SAS. SAS is a supplier, a technology vendor, innovative in statistics, known since many years, but statistics is much more today than somebody analyzing a data set in a corner or in a basement somewhere. So analytics today is everywhere around us, and that's actually what I would like to share a few words about. We see the world is transforming into a world of data, but we want to make it a bit further than just data. It's all about what do we do with this data. And I've heard a couple of times, data is the new oil. You've probably heard it as well. Now oil is just raw material, and we need something to do something with that raw material. Like for oil, we have engines, we have cars. We believe analytics is the engine to turn the raw material, the data, into something useful, a business application or what you could call intelligence. Now, some examples of analytics are very clearly around us and are we touched on a daily basis. I'm sure you have examples of if you use Google search terms, if you visit Amazon and you see recommendations. These are very obvious, clear examples of analytics. Now, some examples are less obvious, but are still there, and I'm going to give you a few of those examples. Now, think of what you did last week, and probably some of you last week have been on an airplane or visited an airport somewhere. Now, you'd be amazed how this industry is being more and more driven by data and by analytics for many reasons. It could be like avoiding delays, optimizing routes, also all the security of the airplanes. There's a massive uptake in number of flights across Europe, across smaller airports that we see, and you'd be surprised, well, not only by also the security that is 2017 was been a record low year of incidents in airspace. So there's a reason for that, and it's due to more automation and the use of analytics for optimizing all kinds of parts of their routes, etc. Another example is, well, if you're flying, you're probably going to an hotel room. Hotels also use analytics to optimize the rooms that they have, the room sizes, the room offers, also the room prices. You'll see that prices differ often from one day to another. All this is also being used, analytics in the background to optimize those. Now, if you look at payments, you've all paid something electronically, not only the last week, but also probably the last 24 hours using a card swiped somewhere, use smartphone applications. All these are obviously interesting for hackers and fraudulent as well. So all of these are monitored continuously with very modern analytical algorithms. Artificial intelligence is looking at are these fraudulent or not, and obviously the reaction time there is very short. You cannot stop any transaction for too long, so you don't want your customers to be unhappy about this. So this is a very data and analytics intensive sector. Other example is manufacturing. So the whole manufacturing industry is using a lot of data, but it's using data mostly for their operational purposes to make sure the machines work correctly. Now we have an example of a semiconductor company, those who are making the chips that are inside your smartphones, to ensure they're working correctly and that they will work as long as the warranty period and even beyond warranty periods. You'll be happy of using that phone. All this quality insurance is also being modernized by using very artificial intelligence techniques, more modern algorithms to make using, for example, pictures of silicon wafers to see where potentially defects could be. Another example is in government sector. We've have the possibility to advise on childcare and trying to find out children or neighborhoods with children where there is a high probability of children being abused or not being grown up in a safe and in a well environment. So there's a way of using analytics to also predict potential problems in that area. A last example is environment. So there's a lot of data for good initiatives around the world for all kinds of things. It could be to fight poverty, it could be to preserve nature, and we've had very interesting cases also using very modern techniques, visual recognition, recognizing a specific rhinoceros on a specific spot by just analyzing its footprint, for example. Using images is an example of making sure nature is safe and continues. Now, if there are such good examples around, still these examples are very scarce, and there are some big obstacles, barriers towards a more adoption of these kind of good examples. Now, they could be people related, they could be process related, they could be technology related, and they could be data related. Now, Organizations need to look at all of these four aspects at a time and to make sure that we have a good balance into how mature are we as an organization in each of these four categories. Now, if I talk about data for a second, well, we all know that there is a lot of data. It's growing by all these activities that we do, that is all being more and more digitalized, so there's no surprise that there is more data, and you can see all the big numbers on the slide that illustrate this. Also, technology-wise, we see there is an abundance of technology, of huge data centers offering all kinds of cloud and other compute power. It is everywhere, and it is very easy, accessible for everybody at any time. Connectivity is another dimension in the technology. Also connectivity, giving access to these cloud data centers, cloud environments is also becoming more and more cheap and more easy, accessible. Bandwidth prices dropping enormously, accessibility for any kind of device to be connected to any other kind of device, uptake of all the Internet of Things devices is all of this is adding to either the possibilities we see due to technology evolutions, as well as the data volumes that are being generated and that all need to be analyzed at some point. Now, I wanted to touch a little word on what we mean by artificial intelligence. So we are a vendor in statistics and analytics since many years, and artificial intelligence as such is not really new. It's a new buzzword, a new term that we see coming up a lot, but it's as such not new. So the first neural networks, they were built in the 70s or maybe even before that. The only thing is that at that point in time, we did not have enough compute capacity to really run them and bring them into the hands of anybody virtually. So we see that today, artificial intelligence becomes accessible due to very powerful computers that we have in our pockets, and it can run very decentralized, so we don't need these extremely expensive infrastructure anymore to do useful artificial intelligence. So how could we define artificial intelligence? Because there are lots of buzzwords in there. Some people talk about machine learning or deep learning or cognitive machines, etc. So this is all, let's say, this similar, not really synonyms, but similar terms to identify algorithms, machines who learn from data, from activity to be able to perform tasks autonomously or independently up to a certain degree. Now, I talked a little bit about data before, and the data is there, but of course, if the machine is going to learn from the data, you'll understand that the way we manage data and that we keep control of the quality of the data and guarantee the data is good, then the machine will learn something useful. Because if we give bad data to the machine will learn bad things and do wrong things with what it has been learning. No matter how good the intelligence is, learning from bad data will not give us a useful solution. I'm going to end by 3 other examples of cases that we've been doing here in the region, the countries here and the countries around us. And, oh no, sorry, one more thing. What artificial intelligence is not. It's equally important, of course, to understand what it is not, because sometimes it's seen as some magic solution, could be driven by Hollywood or other initiatives, but it is not like a magic thing. It is still mathematics, it is still learning from data, and it is still, there are still ways to explain what actually the algorithm is doing. And we believe it is pretty important to have algorithms that are understandable and that we can explain what they are doing, because algorithms could be like really black boxes learning autonomously by themselves and starting to do maybe at some point rather unpredictable things here. So I was going to end up with a few more cases, so let me quickly skip, this is not so important. A case where I was working on recently is in the Netherlands. Actually, we were working with the Amsterdam University, who's doing cancer research. And actually I found very innovative ways to analyze many digital pictures of patients. And what they're specifically aiming at is to do a very early detection of cancer from pictures and from other data, but where they have had very early pictures from patients who have developed cancer in a later stage, where it was rather invisible to see it on the early pictures. Now the computer can see things more than we can, or they can analyze more pictures, they can see pictures from thousands of patients, where a doctor in his whole life will only see a limited set of patients, of course. So we're trying to see if the algorithms can help the doctor get a more or a better outcome or a better definition of what he sees in the case of his patients. Another example is in sports. So we're working with a startup who is analyzing activities of football games, and they're doing several things with this. So they put cameras alongside the whole field, and analyzing sports as such is not new. What was done before is that companies put people in the audience that have to take track of every activity that they see on the field. So whenever everybody is tasked to look at a specific player, where is he? Does he have the ball? Does he win a duel or not? Is he falling? Is he standing? What's he doing? And so instead of having people recording all this and making mistakes by recording that, they now have a system that analyzes it with a number of cameras, that looks at the whole field and that tries to predict what is happening on the field. And they do several things with this. One of the things they're doing is give advice to football companies to say, well, look, your defense is weak. You should buy that player from that specific team and don't pay more than this price, by the way, because it would be very interesting to have your team with this specific player. And the last one, well, actually the same one. It was just to, yes, not so important. Last one is on traffic. So we're doing a project in the Netherlands where they are looking at, not sure how you say it, the locks is one of the things they're doing, Rijkswaterstaat, trying to, well, if a lock is broken, it is sometimes broken for 6 months before it can be repaired, because these are very big infrastructure elements. Of course, it is a big problem if it is down for too long time. So they're using techniques to better predict failure of specific components so they can be changed and do preventive maintenance on these locks before they totally break. And I think with that, just one more thing. Well, if you're having data but you're not analyzing it, you're having some value that you're actually not realizing.